Welcome to chapter 5, everybody. Turn to page 232. We're going to start with 5-1, angles of triangles. Now, some of this stuff might be something you've seen already, and some of it might be just completely new. I'm not sure, everyone's different, but ideally by the end of the chapter, we're going to do so much with triangles that you're going to be able to look at a triangle and have a pretty good intuition about a lot of the different properties, whether or not you can name them specifically, okay? Because we're going to do a lot of vocab and we're going to do a lot of things with angle measures. So let's start at the beginning though. Copy down the core concept on page 232 while I switch my screen, and we're going to do some drawings at the bottom of the page. Now, you should have paused and resumed, and if you didn't, then remember, you should pause and then resume when you're ready. Now, if you look at the bottom page on page 232, number 1, it says to draw an obtuse now this is something that I always make sure I spell correctly because it's kind of hard to, it's easy to misspell the isosceles. So an obtuse isosceles. Now, of course, I'm going to write a little triangle instead of triangle, right? So this is not my drawing. Okay, we know that an isosceles triangle has two sides of equal length. So the problem is I just need an obtuse angle in there. Now that's going to be the angle in the middle of the two equivalent sides. I mean, think about it, right? If we have a triangle and it's isosceles and one angle needs to be greater than 90 degrees, right, for a triangle, then the other two angles are going to be less than 90 degrees when you add them up. Right, so these are the two sides that are the same. Here is my obtuse angle. Figures not drawn to scale, and then these two angles, of course, are going to be congruent because it's an isosceles triangle and they're across from the congruent sides. So here is an obtuse isosceles triangle. And now they want us to draw a acute scalene triangle, acute. So there's going to be an angle smaller than 90 degrees. Now, I would imagine that, well, never mind. We'll find out the properties on our own without your teacher giving it away. So we just need to draw an acute scalene triangle. So I'm going to do my best to make sure it doesn't look like any of the sides or any of the angles are equivalent. So let's see. Of course, I just naturally somehow managed to draw right triangles. So you know what? That's too much like a right triangle. I mean, I really am just kind of, it still looks like too much like a right triangle, but you know what's going to correct it? These are 3 tick marks, 2 tick marks, 1 tick mark, and none of them are boxes that signify a right angle. And here you go. Maybe it's not the most perfect thing in the world. Maybe there's better artists out there. I bet that there are. All right. Now, we can also, I probably should have used my graphing notebook for this. Oh, you know what I'm going to do real quick? I'm going to pause. I'm going to do a new share, actually. And we're going to go ahead and we're going to go to Geogebra. So remember, we can get to that through Big Ideas Math, or you can just type in Geogebra. Sorry. Hopefully you don't see my arm anymore. Well, you know what? I don't feel like typing my username and password because that is easier. So in Geogebra, we can do number 2 at the top or near the top middle of page 233. So we have a triangle and it has vertices at 0, 0, 3, 3, and -3, 3. And of course, I'm going to, I don't need to measure anything. I'm going to make my line segments to connect so that we know it is a beautiful triangle. All right, so we have a triangle here, coordinates 0, 0, vertices 0, 0, 3, 3, and -3, 3. And they want us to determine whether, classify the triangle by its sides and then determine whether or not it's a right triangle. Ooh, that's interesting. So first off, it looks like, and let's see if I can get the colors going. Oh, not right now. So it looks like we have one line here and another side here. Sorry, one side and two sides. Side AB and side AC are the same length. Now, you have a couple ways of doing this, Munchkins. You can do the distance formula, which I will do for you to refresh your memory. Or in this case, I mean, you can think of it as we really are going to go up 3 over 3. What's that? Does that sound like a familiar word? Or down 3, right 3, right? And since we know the endpoints are the same distance away from the origin here, we could assume assume that these are equivalent sides, which makes an isosceles. Now, we of course can tell that line segment BC is not going to be the same, so it's not equilateral. So it is an isosceles triangle. Now, the next question is whether or not it's a right triangle. So I'm going to take a moment and I'm going to sketch it myself. We are going to do the distance formula for when we need to do the distance formula. We're going to get shapes that we can't determine. And then that's going to help us figure out if it's a right triangle or not. Because looking at it, really can't tell. So let's see, we have -3, 3. We have 3, 3, and we have 0, 0. We have A, we have B, and we have C. Okay, back to my notebook, and maybe it was a mistake to go to Geogebra. However, you know that Geogebra is a lot neater than my writing. So first off, determining whether or not it's isosceles. Now, I could do the distance formula for everything, but guess what? This is easy. What's the distance from -3 to +3 on a nice straight horizontal line? We know that this distance is 6. Do you remember how to do the distance formula now? Because, you know, it's nice to assume, but that doesn't mean you're right. So let's find out what is the measure of line segment AB. So that's going to be the square root. This should sound familiar if you were with me in fall semester. We are going to do the difference of the x's squared plus the difference of the y's squared. Okay, take out that thing. 3 minus 0 squared was 3 minus 0 is 3. 3 squared is 9. 3 minus 0 is 3. 3 squared is 9. Square root of that, and this is the square root of 18. Now, it's going to be the square of 18. We just need to compare it to see if this is the square root of 18. However, for those of us that have had the practice, this is the same as the square root of 9 times 2. We know the square root of 9 is 3. We don't know the square root of 2. So the distance is 3 rad 2. Or we put it into a calculator because it's kind of weird to say the distance from my house to school is 3 rad 2. Let's do the distance from C to A or A to C. So AC, I'm going to do the square root of the difference. See my pattern? See how I think about it? We should think about it the same way. You should think about it the same way. The difference of the x's, -3 minus 0 squared, plus the difference of the y's, 3 minus 0 squared. Notice I'm consistent with which point starts and which point ends the parentheses. -3 minus 0 is -3. Squared is +9. 3 minus 0 is 3. 3 squared is 9. 9 plus 9 is 18. And this would be rad 18, which is the same as rad 18. And of course, for us, for our future of the 2 students, it's 3 rad 2. So 3 rad 2 and 3 rad 2, these are the same. So I confirmed it is an isosceles triangle. 3 rad 2, 3 rad 2, 6. Is it a right triangle? Well, let's go with the first visual thing I did to assume lengths. I actually used the slope, which is ridiculous because slope doesn't really have anything to do with length. What is the slope of this line? Well, we went up 3, right 3. So the slope of AB, so that's a little AB, is up 3, right 3, and that simplifies to 1. What is the slope of AC? We're going to start with C. We have to go down 3, right 3, and that's -1. So if these two lines are perpendicular to make them a right triangle, they're going to be opposite reciprocals. Opposite, they have different signs, opposite signs. If one's positive, the other's negative. Check. Reciprocals, they are reciprocals of each other, not the signs, just the numbers. So what is 1 over 1? It's 1. What is 1 over 1? It's 1. They're reciprocals of each other, right? 1 over something is its reciprocal. They are opposite reciprocals, which means this is a right angle. And so it is a right isosceles triangle. So it's an isosceles triangle and it's a right triangle. All right, that was a lot of math. You might want to pause and work your way back to look at it again. If you need to refresh your distance formula, look in your notes or go on IXL. If you need to refresh your slopes, how to find slopes and opposite reciprocals to be perpendicular to form a right angle when they intersect, well, then you can find that on IXL as well, probably in Algebra 1 and or 8th grade. All right, take a deep breath in. Might be a long video. It's going to be all of Chapter 5, Section 1. But guess what? There's not much more to do. So you are going to pause the video after your deep breath in, and we are going to talk about Theorem 5.2. All right, the exterior angle theorem. Now, normally I say, hey, copy it down. If I'm writing it out, it must be pretty important. So we have a triangle, right? And all angles inside a triangle add up to 180. And we have this angle 1 right here. So the measure of an exterior angle, an exterior, it's outside the triangle. We all agree upon that, right? On that. The is going to be equal to the sum of the other two angles that aren't adjacent, non-adjacent, the other two angles that it's not touching. So in other words, the measure of angle 1 is going to be equal to touching angle C, interior angle C, the measure of angle A plus the measure of angle B. In fact, let me get my highlighter out. So, got to find my highlighter. See a lot of markers, no highlighters. So, the measure of angle 1 is going to be equal to the measure of angle B plus the measure of angle A. Add these two together and you get that one. Think about it. This is a straight line, so the interior angle C plus the measure of angle 1 is going to equal 180. Oh, think about it this way though. This plus this equals 180. So the measure of angle 1 is equal to the measure of these two angles added together. All right, but corollary. Now, this might seem a little silly, but it's kind of important pointing out. Remember, we're going to learn so much about triangles that you're going to be able to look at it and know it, or have an intuition. Top of page 235, the corollary to the triangle sum theorem. Now, if I went too fast because I didn't talk about it, the triangle sum theorem is that all angles inside a triangle add up to 180. Well, I know some of you are going to say, no, duh. Well, kids, it's math. Of course it makes sense. If we have a right angle, angle C, well, then guess what? Maybe we just don't need to keep adding them all up to 180. Why don't we just know that the other two angles have to add up to 90 anyway, right? 90 plus 90 have to be 180. So if we know this is 90, maybe we can just say, hey, these two are going to be 90, right? Cool. Let it sink in. Look down to the bottom of the page. Draw number 3 with me. This is page 235. Number 3. Ooh, you know, big reminder though, because it's the beginning of a new chapter. I probably said some stuff you might want to take notes on. So it is okay to pause these videos, go back, add things to what I say. I'm just saying them. They're on the internet now forever. You can always go back and add to them. I'm trying to help you out here. So we're looking for the measure of angle 1. Okay. Oh man, why didn't they put that inside? All right, so I'm thinking of things, right? There's stuff going off in my brain. Notice these are all different ways of knowing that these angles are probably not equal to each other. All right, we're looking for the measure of angle 1. I'm going to put that in a nice highlighted circle. Okay, so I know, what do I know? I know that angle 1 plus all this is going to equal 180. But I can only solve an equation with one variable. I don't know what this is, and I don't know what x is. I don't know that these two are equal to each other, and I don't know that these add up to 90. I do know that this plus this equals 180, but then again, I got two variables. Oh, but I do know that 5x minus 10 has to equal 3x plus 40, right? The measure of an interior angle is going to be equal to the sum of the non-adjacent angles. Adjacent, non-adjacent. So add them together. All right. So let's solve. Take away 3x from both sides. Add 10 to both sides. 5x minus 3x is 2x. Negative 10 plus 10 is 0. 3x minus 3x is 0. 40 plus 10 is 50. Divide by 2 on both sides, and x equals 25. Did I figure out what it is? So is the measure of angle 1 25 degrees? X equals 25. Is the measure of angle 1? No. I'm looking for the measure of angle 1. I found x. Oh, well, guess what? At this point, you have options. You can plug x in here, figure out what this is, take it away from 180. You could plug x in here, figure out what this is, add it to 40, take this away from 180. It's up to you. And I'll actually let you go off and do it on your own. But I'm going to use what I said first. So 5 times 25 minus 10. 5 times 25 is 125. Take away 10 is 115. All right, so this right here is 115 degrees. So what is angle 1? Well, the measure of angle 1 is going to then be 180 minus 115. And you are going to answer that in the Ed puzzle right now. And we're back. All right. Something similar. We're just practicing our skills. Depending on what time of day you're watching this video, you might be fresh, you might be tired. It's all right. Number 4 on page 235. And since I am not the same as a computer, we're going to go with that. Okay, here's a triangle. We know it's a right triangle. 2x degrees, x minus 6 degrees. Find the measure, find the measure of each acute angle. All right, so what do you want to do? Well, this is 90 degrees. This plus this plus this equals 180. This plus this equals 90. 2x plus x minus 6 equals 90. Combine like terms. 3x minus 6 equals 90. Add 6 to both sides. And divide by 3. 3 goes into 9 3 times, 3 goes into 6 2 times. X equals 32. Did that solve the problem? No. One angle is going to be 2 times 32, which is 64 degrees. Go ahead, plug in 32 to the next angle, take it away, and tell me what it is in the Ed puzzle. And then good job. Make sure you get to the end of the video, and then you will get a grade on Ed puzzle.